Hello friends, today we are going to learn about pulses. The pulses or legumes are edible fruits or seeds of pod-bearing plants. They help in improving soil fertility by fixing atmospheric nitrogen with the help of bacterium rhizobium. They provide nutrition and are the main source of protein for all the vegetarians and vegans. Common pulses and legumes that we eat are black gram, red gram, green gram, rajma, lobia, etc. Coming to the nutritional value, the total energy provided by pulses is similar to that of cereals, that is 340 kilocalories per 100 grams. Pulses provide us 55 to 60% of carbohydrate, 20 to 25% of protein, and 1 to 5% of fat. The pulse protein lacks methionine but is rich in lysine, whereas cereals lack lysine but are rich in methionine. Together, they can complement each other and provide us the required essential amino acids. If we take 8 parts of cereals and 1 part of pulses, the protein quality almost gets similar to that of animal protein. Pulses are a good source of omega-3 and omega-6 fatty acids. When we combine pulses with cereals, they can meet our 100% of essential fatty acid requirements. Pulses are rich in B-complex vitamins but lack other vitamins. However, by germination, the vitamin C content of the pulses can be improved. Pulses are not quite significant source of minerals if we take into account the amount that is consumed. Few minerals which are present in pulses are often found complexed with phytates. Phytates also bind the proteins. To make the nutrients more bioavailable, the phytates can be reduced by cooking, soaking, germination, and fermentation. The antioxidant value among legumes is highest in rajma and soya bean and can be increased by various processes. Due to a very high molecular weight and a compact structure, it becomes difficult for our body to digest pulses. Various anti-nutritional factors like trypsin inhibitor, polyphenols, phytin, oxalate, crude fiber make the process further difficult and interfere with absorption of various nutrients. Among all the legumes, the chickpeas have highest digestibility. On various levels, processing of pulses is done to improve the appearance, texture, cooking quality, palatability, keeping quality, and nutritional value of the pulses. In milling or decortication, the outer seed coat of the pulses is removed. To remove it, wet or dry processes are used. In dry method, we get hemispherical, good flavored, and easy to cook pulse. In wet method, we get flat pearls with depression in the center, which often takes longer to cook. If a seed coat is more tightly bound, we, after linseed oiling, get it sun-dried 2 to 3 days, which loosen the husk. Milling reduces the quantity of fiber, increases the digestibility of protein, net protein utilization of pulse, and overall nutrient availability. It also reduces the anti-nutritional factors like polyphenol, 80 to 90% of which is present in seed coat only. The hard outer covering of the whole grains can be softened by soaking in cold water overnight or at 60 to 70 degrees Celsius for 4 to 5 hours. Water enters through xylem and makes the pearls tender, decrease phytic acid and oligosaccharides. The water-soluble vitamins are often lost in this process. To prevent this, the soaked water should also be used. For germination, the overnight soaked whole grains are drained and tied in loose woven cloth. Then they are hung and sprinkled with water 2-3 times a day. Germination occurs in the seeds in a day or two. The moisture and warmth are essential for germination. Pulses like green gram, Bengal gram, dry bean, and dry peas can be germinated. Their nutritional value and nutrient availability can be improved. The anti-nutritional factors like trypsin inhibitor and phytates decrease, proteins and minerals are released from the bounded form, and digestibility also improves. Vitamin C is synthesized by the activated enzymes, and the content of it is maximum after 30 hours of germination. Germination also reduces the mucus inducing property of pulses, decreases the content of oligosaccharide that produce flatulence as they get metabolized, the cooking time decreases, and taste and texture improves. Germination also adds variety to our diet. During fermentation, the microbial enzymes break down legume protein and fasten the cooking process. This increase the digestibility, increase the palatability and nutritional quality of the pulses. The processes like parching and puffing add variety to our diet. Legumes like Bengal gram and peas can be parched, and chickpeas and field peas can be puffed by mixing with preheated sen at 250 degrees Celsius. The only difference is we just sprinkle some amount of water on the grains before roasting, but in puffing we soak the seeds beforehand. The parched Bengal gram has been successfully used for the treatment of protein energy malnutrition in children. In extrusion, the blends of cereal and legume flours are cooked for a short time and then extruded at high temperature and pressure by variety of dies and dried on conveyor belts. The extrusion process also helps in adding variety to our diet. The nutritional value of the pulses can get reduced during processing or during home cooking, and also when we store them. With long storage periods, the beans become more and more harder. The phytate content and PCMP increase. All of these factors increase the cooking time of the pulses. Once the grains gets infected, it decreases the nutritive value like protein quality of the pulses. Heat damage can also cause lower availability of essential amino acid lysine. In legumes like red gram, Bengal gram, cowpea, double beans, soybean, Lathyrus sativus and peas, we find toxic constituent like trypsin inhibitors. Its basic function is to prevent protein degradation during seed maturation. In humans and animals, it decreases the activity of enzyme trypsin and decrease the protein digestibility and utilization. This can result in enlargement of pancreas and growth retardation. Processes like pressure cooking or autoclaving at 120 degrees Celsius for 15 to 30 minutes can inactivate almost all of the trypsin inhibitors. Only for kidney beans and soya beans, we require more drastic treatments. Lithyrogens are a kind of neurotoxin found in kesari dal or Lathyrus sativus. It is grown in dry areas of Madhya Pradesh, UP, Bihar, West Bengal, Maharashtra, Mysore, and Andhra Pradesh. If eaten in small quantities, it can provide 28% of daily protein. But if we derive more than 50% of energy from it, it can cause spinal cord nervous disorder in 15 to 45-year-old men. As it resembles Bengal gram and red gram, it is used as a common adulterant in them. It can cause lethyrism, and the neurotoxin responsible is known as beta-N-oxalyl L-alpha-beta diamino propionic acid. The common symptoms of lethyrism are muscular rigidity, weakness, and paralysis of leg muscle. The development of the disorder has been divided into 4 stages. In the first stage, the person walks with small steps and jerky or crossed movement. The person can remain in this stage for the whole life or pass on to the second stage. In the second stage, the person uses a stick to move as he is required to tilt his pelvis due to increased muscular stiffness. In the third stage, 2 sticks are required for support, while in the final stage, the person starts to crawl on hands. No upright walking is possible. The neurotoxin lithyrogen can be removed by steeping or parboiling. In steeping, 4 times water then seeds is taken and boiled. Seeds are soaked in hot water for 2 hours, then water is drained off and seeds are washed with cold water and sun dried. This method can remove 80 to 90% of toxins. Parboiling, the seeds are soaked in cold water for 12 hours, then steamed for 20 to 30 minutes and again soaked for 1 hour and dried. This method can also remove 80 to 90% of the toxins. ICR has developed Booster 24 and LSD6 varieties of Lathyrus sativus which have only 0.2 to 0.3% of the toxins. The people of the affected region should be made aware of the disease and they should be encouraged to remove the pulse from their diet by recognizing early symptoms. In faba or broad beans, we find glycosides like vicin and covicin, an amino acid derivative DOPA or dihydroxyphenylalanine, which can cause favism in people who are deficient in glucose 6-phosphate dehydrogenase. It can cause hemolytic anemia and decrease glutathione levels in RBCs. These compounds can be reduced by germination and boiling. Hemagglutinin, phytoagglutinins or lectins found in legumes like soybean, field bean, white bean, double bean and horse gram. They protect the plants from fungal attack and insect infestation. In humans, they interact with enzymes like dipeptidases and disaccharides. They also interact with the small intestine, overall affecting nutrient digestion and uptake, resulting in poor growth. They can be reduced or eliminated by heat treatments. Cyanogenic glycoside yield hydrocyanic acid after hydrolysis and can cause cyanide poisoning, which interfere with tissue respiration. All the legumes have cyanogenic glycoside in safe limits except lima beans. The saponins are found in soya bean, which produce foam when shaken with water. They are glycosides of high molecular weight and can cause nausea and vomiting. They can be eliminated by soaking the soya beans prior to cooking. The goitrogens like thiocyanate, isothiocyanates and their derivatives found in soybean, groundnut and lentils interfere with iodine uptake. If you are taking a diet low in iodine and high in goitrogens, this can result in goiter. Tannins are condensed polyphenolic compounds found in seed coat of most legumes. They affect the activity of trypsin and alpha amylase. They also affect the absorption of proteins, B vitamins and minerals like iron as they bind with the iron irreversibly, making it unavailable to the body. Removal of seed coat improves the appearance, texture, cooking quality, palatability, digestibility and bioavailability of nutrients. The white beans have lowest, while black gram, soybean and kidney beans have highest amount of tannins. The pulses are quite rich in protein and B vitamins. They improve the quality of cereal protein and provide satiety due to the presence of fiber. They are used in different preparations and as thickening, stuffing and seasoning agents. The pulses have different components which reduce the risk of various diseases. They are more capable of reducing the postprandial glucose spike than carbohydrates. The phytates reduce the risk of colon and breast cancer due to the antioxidant effect. The oligosaccharides promote growth of bifidobacteria and thus colon health. They also reduce the risk of colon cancer. In cluster beans, we find guar gum, a galactomannan polysaccharide capable of forming viscous gel in the small intestine. It decreases the cholesterol absorption and binds bile acids which mobilize more of cholesterol from the body to form bile acids, thereby reducing the total body cholesterol. Other than this, the processes like germination result in increased ratio of omega-3 to omega-6 and prevent us from degenerative diseases. The amount of eicosapentaenoic acid and docosahexaenoic acid is also improved. Black gram have high omega-3, so it can reduce cholesterol if consumed regularly. The cowpea also has cholesterol lowering effect.